So let's talk about computers. In reality, they are not easy to build, not by any stretch of the imagination. I mean, yeah, you can assemble them, order all the parts, make sure they're compatible with each other, um, put the whole thing together, hope it works, understand what the beep codes mean, resolve them, boot it up again, hope whatever issues you ran into before are fixed, and clap and cheer, or maybe do a happy dance or something like that when the thing actually does work. Okay, maybe that was just me, but what I'm trying to make is computers are hard to build. In real life, here, they're complicated enough to require manufacturers, but that's beside the point. Which one of these buttons was it? Ah, here we go. To start building computers, I'm going to build circuits. Now, I don't think I'm going to need a consistent flow of circuits. I'll just wait for this land wheel to get out of the way. There we go. Yeah, my official position on this, on that, whatever it is that it is a land whale. It walks on land. It makes whale noises, and well, it was the first name I thought of when I saw it. I understand that there are other names in the community for it, including one with a bunch of hyphens in it that's a little bit too long to say, in my opinion. But that's beside the point. Alright, so to build computers, you have to first build circuit boards. I mean, you can't exactly order them online like you can in real life, because there are so many different kinds of circuits computers need, but that's, again, real computers as opposed to these computers. They're just copper sheets and plastic. And the circuits require an assembler. The computers require one of those big... I hesitate to say honking or chonkers or any form of the word chonk, because maybe it's like saying totally radical anymore. I have no idea what's in and what's out, and I stopped caring a long time ago. Alright. How to make a computer. Let me just put this down, because... Okay, I want to make computers. Circuit boards, cable, and oh yeah, plastic. What does this mean? Simply put, that I'm going to need to move this box, which I was kind of concerned about. Or maybe make another box and fill it with plastic too, but... Now, very honestly, this is going to be a one of those things where I want this stuff, but not an infinite supply of it. Just a big supply of it. Now, big is big, but it's not infinite. So, what I'm going to do is take a box, not even a big box, just a regular box, and split the output of it. Part of it goes to the assembler, part of it goes to the manufacturer. Now, granted, it's not going to be equal parts, but I'm not exactly going for that right just now. Just put my... And yeah, there's loads of plastic available in way back at Freighter Lake. The power plant comes up with it constantly. Which is a bit of a reminder that I need I need more. Well, I need a better way of making power, one that doesn't have byproducts. Now, I suppose I could take like a train and connect a track to where the plastic is put. But then, again, that's assuming that I need to make a consistent supply of plastic, and the answer to that is I'm guessing no. Alright, so, where's there a free node? Do I have a free node? No, I do not have a free node. Oh well, next best thing. String this up, string that up, and I think the only problem I'm going to have with this is that the circuit boards are going to build up in the assembler. Oh, there are the cable spools. Yeah, I was beginning to get a little worried there. Still, I've got a constant-ish flow of computers, and for railway signaling, I'm going to need computers. I'm not sure whether I'm going to need railway signaling or not. Alright, so I'm going to stock up on... Actually, before I do that, I need to utilize the Caterium node. At Precipice Caterium. It's a node, it's fallen off the edge of the map there, but... Wait, is that really the edge of the map? I have really no idea. It's an edge. Welcome to Back of the Envelope Calculation Theater. We have a pure Caterium node. I can put a Mark II miner on it, but underclock it to 180 a minute instead of the full 240. Why? Well, because of the way smelting Caterium works. It takes 3 units of ore to put out 1 ingot, and smelters work at 45 units of ore a minute to put out 15 ingots a minute. Now I'd take the output of each smelter and put it into a quickwire constructor that's overclocked to 1 1/4. Why? Because ordinarily they only take 12 ingots a minute and put out 60. But I'd have to combine the outputs of the smelters together and then split them up 5 ways, which may or may not be impossible. If it is possible to do it, it's not all that easy. It's much simpler just to overclock the constructors. Now, I'm going to take each of them at putting out 75 a minute and combine the outputs into one stream of 300 a minute, and then put that into a box. And I'm going to let that run until that box is full. It's going to be one of those industrial boxes, so double the capacity of an ordinary one. Now, quickwire is used to make 2 things, or at least 2 items anyway. The AI limiter and the high-speed connector. And both of those require copper, but there just happen to be a couple of copper nodes nearby where the Caterium node is, or at least near enough by. It's just this side of feasible. So, they're both impure, so I can put a Mark II miner on each of them. Now, the first one I'm going to underclock to 50 a minute, and overclock the smelter so that it can take the entire output of the miner. Then I'm going to split it 3 ways, but it's not going to be an even split. They're all going to make copper sheeting, but one of those copper sheet constructors is going to be underclocked to half capacity. So I'm going to have 25 copper sheets per minute. That's what's required to make AI limiters. So I'm going to take 100 Caterium wire, or quick wire from the box to make the AI limiter. That's the per minute rate there, by the way. And I'm going to put the output of that into a box and run it until I have, well, a lot of AI limiters. As of right now, I need them for research, at least mostly. things might change. Now the other copper node is going to be used to make the high-speed connectors. Now, it'll be underclocked to 52.5 a minute, which is kind of a weird number. But it's the smelter is going to be overclocked to take the entire output again, and then it's going to be split 3 ways too, but not quite the same. It's going to be split 2 ways, and then those 2 ways are going to be split 2 more ways. So, right out of the smelter, it's going to be split 2 ways, and the first way that split is going to be into a copper sheet constructor underclocked to 3/4. The other 2 are going to be split evenly into wire constructors overclocked to 1 1/4. And then the outputs of those will be combined and fed into a cable constructor of 1 1/4. Now that's 37.5 cable a minute, and that's going to be fed into a high-speed connector constructor. Or sorry, actually it's a manufacturer with that many inputs. A high-speed cable manufacturer, or high-speed connector manufacturer, that takes 37.5 cable a minute, 3.75 circuits a minute, and 210 Caterium wire a minute. Now to make circuits you need plastic. So I'm going to have to import some from Fritter Lake. That's going to be fed into a circuit assembler operating at half capacity at a rate of 15 a minute. The copper sheets are being output at 7.5 a minute, and the circuits are being output at 3.75 a minute. And the whole thing's going to make high-speed connectors, and it'll be put into another box. Again, high-speed connectors are also in demand, but mostly for research. So I need a lot of them, but not necessarily an endless supply. So while I was building this thing, here are some highlights. Alright, well, here's the railway signaling. Milestone reached. Train signals placed on train rails can control and improve train behavior. This helps to avoid events where multiple trains attempt to occupy the same physical location. For information related to earlier train events, please refer to your employee non-disclosure agreement. What a lovely euphemism. Events. Yeah, Casey Jones was in an event like that once. Okay, I got another milestone. Pipeline engineering. That requires more plastic, but I think I can just stop by the Fritter Lake and pick up plastic and rubber. Actually, no, let's strike that. Is this thing finished already? Whatever, I'll just resupply it. Okay, here we go. 1, 2, 3, 4, 5. Oh wait, I keep forgetting that I gotta wait for that pod to come back. Alright, well let me grab more rubber, because I'm gonna need it for another milestone. That's another thing. I'm gonna have to build a route that goes directly to where the plants are, so let's see if I can cycle through. I can't, okay. I was hoping to make ramps. There. there, 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 there. That's in the way, but if I were to put, well, it always does this. As soon as I want a 45-degree angle. Here. There we go. Now I got a nice way up here. Oh, it's back. Well, I'm a bit busy right now. Well, it looks like we're ready for Pipeline Engineering Mark II. Milestone reached. Pipelines and pipeline pump can now be upgraded to Mark II. They're like Mark I, but better. Pipes seem to be an object of fascination to humans. In fact, there are recorded instances of humans doing nothing but thinking about pipes for hours. Interesting. You know, there was a screensaver back in the days when there were such things as screensavers. And it was like these pipes being drawn in 3D into some kind of weird random pattern. I mean, I thought it was pretty cool. I don't have enough computers for the next milestone, and I need to get in more plastic. Probably more rubber too. So oscillators require 3 things: quartz, cable, and reinforced iron plates. And since they require the most quartz, I think I'm going to build where there is the oscillator manufacturer, the oscillator manufacturer where there is the most quartz. And that will be in the quartz cavern. Before I do anything like that, I gotta take some supplies that it needs that aren't there. Reinforced iron plating, for example. 1, 2, 3, 4, 5, 6, 7, 8, and go up and grab some cable as well. Be over here. 1, 2, 3, 4, 5, 6, 7, 8, and lastly, I'm going to turn on the miner and get all this running again. I mean, I've got copper sheets, but and yeah, I know my tractor's out of fuel, but I think I'm nearly full to capacity on iron pipes, and I mean steel pipes, and possibly steel beams too, but I'm not sure. Got a couple more I'm thinking about it. How to get the heavy manufacturing, heavy modular frame plant going again. It's always short on encased industrial beams. Needs 5. Divide that by 100. Sorry, divide 200 by 5. That's 40. 40 more. Bringing us to a total of 59. I'm gonna have to go back to the concrete place and get encased industrial beam manufacturing started again. But well, that one milestone that required all the concrete certainly set me back.